Welcome to a video on curve sketching part 1. Suppose you're given some information about a graph and you're supposed to sketch a possible graph. So this might not be a unique graph, but it should satisfy all the conditions provided. So first, I always start with the original function, not the derivative. And here we have f of -2 is equal to -4. So you just plot that point. Then let's look at the derivative. We are told the derivative is constant equal to 1, so slope is 1, for all values of x greater than -2. So you could see the red line that was drawn. It has a constant slope of +1. Then we have a constant slope of -1 for all of the x's that are lower than -2. And that finishes off this part of the graph. Now for the second example, we have not been provided any information about the original function. We're told something about the second derivative and the first derivative. But it is still possible to do a possible graph. It's not going to be unique though. So we're going to start off by looking at the subdivisions of the x values. If you look at the inputs provided at the end here, we have -3 and +1, so that's the ones that we want to use. And also that this -1 subdivision where the second derivative changes at -1, that's the key value that we're going to concentrate on. All right, so here we have the first derivative. It's flat at 2 values of x. So I have written down that we're going to have a horizontal tangent at somewhere along this x value of -3 and this x value of +1. Now we're going to tackle the second derivative part. So you're told here that it's going to be a negative second derivative, which indicates it's going to be concave down function for all the values of x that are less than -1, and then concave up values for x greater than -1. So we have concave up for values that are greater than -1. Now, this part here shows that we have a horizontal tangent exactly at -3, and it's constantly concave down on this particular region. Now, I didn't know whether to have it drawn this high. I could have had it actually drawn over here, this U shape, as long as it had a flat slope at -3. Okay, and this last part, we want a flat slope at +1, x equals +1, and all of this has to be concave up. This particular point where it switches from concave up to concave down is called an inflection point. In the following question, I have provided for you a table that shows you the signs of the original output y values, the signs of the derivative or slopes, and the signs of the second derivative or concavity. I've also provided 3 key points for us to plot. Now, these points are not just random points. They're actually the same x values that subdivide this table. So first of all, you plot those points. Then you notice that the y values are always positive, so you know that your graph will always be above the x-axis. Then the derivative being negative in this region implies that there's going to be decreasing graph here, or slope would be negative. That implies that outside of that region, it's going to be the opposite, increasing graph, or slope is positive. Now, the slope is 0 at this value, so that's indicated by a little dot, but infinite at this value. So I'm going to draw a horizontal tangent slope there and a vertical tangent slope here. Then second derivative being negative implies that the graph is concave down. which means outside of that region, it's concave up. So this is indicating that y is going to 0 as x goes to negative infinity. And it has to approach this asymptote from the top because y values are always positive there. And so now we can start doing this graph. We have flat slope here. We have concave down up until this point, then inflection point and concave up and approach this horizontal asymptote. Then we have concave down decreasing portion, and then we have an infinite or undefined slope at this point. Then we have an increasing graph, which is always concave up. Let's do a second example in the same way. We are given some values here, same x values as provided in the table. Remember that this table you would have to be creating yourself, and I'll show you how in the next video. So start by plotting first of all the points and a vertical asymptote at x equals 4 because we have undefined value there. Notice if the original graph is undefined, then the derivative and the second derivative will also be undefined. So start with the y values. We have positive values, so above the x-axis in these regions and below the x-axis in the other regions. Then we have negative slope or decreasing graph from this point all the way to 9.29. That means it's going to be increase on the other side. Then we have zero slope at these two values, so we have flat slope or horizontal tangent here and here. Then we have a VA here, so we've already discussed that the derivative would not be existent if the graph is not there. Then the second derivative being positive implies we have concave up on this side, so that means it would be concave down on the other. And now we begin by graphing it. We have a flat slope, horizontal tangent, and this region is always concave up. Here we have flat slope, decreasing and concave down. And on the other side also concave down, but this time it's increasing.